Bismillah ar-Rahman ar-Rahim. Assalamu alaikum students. This is a paper October 2023 and variant 43. Mechanics paper. Let's try to solve. A particle is projected vertically upwards from a ground with speed of v. And the particle has height of s meters above the ground at times 3 seconds and 4 seconds after projection. It means this. So when we throw a particle from here, it will naturally go on the top, stop here, and come down. There's a natural process. But in the process, in the whole process, 2 times, one first here and here. So this height is s meters. It is very clear mentioned here, s meters. And first time is here to reach this height is 3 seconds. And this time, second time, you reach same height while coming down 4 seconds. So one going up, the second coming down. So it is very clear. And naturally, if I ask what is the middle time, because the average going up and coming down time is 1 second, because 4 minus 3, 1 second, 4 minus 3, 1 second, starting here, reaching here, time 1 second. So naturally, half second to go up, half second to go down. So I think I can say that the total time from ground to this one, so time is 3.5 seconds. How come? Because he said that this is 3 already given by him as a 0.5, so 3.5 seconds. And you know, the peak, it stops. When it stops, so naturally last velocity is 0. And this velocity is u starting from here. So that is very clear. U is equals to u, final velocity 0, going upward gravity -10, and time is very clear, 3.5 seconds. So v is equal to u plus gt. Last velocity 0, u unknown, gravity -10, and time is 3.5. And if you solve it, it is becoming -35. So u is equals to 35 meter per second. Alhamdulillah Rabbil Alameen. We have done the first part. We have more methods even, but I think this is an easy way for you to understand. Now, again, I will, because our concern is to find the distance s meters. And okay, I will use a second data. Starting velocity now 35, we know it very well. We don't talk about the top. We talk about this distance here. So that's s is equal to s unknown. And going upward, gravity is naturally -10. And time is reached at this point is 3. So time is equal to 3 seconds. So s is equal to ut plus half gt square. S is unknown, u is 35, time is 3, half times 2 -10 into 3 to power 2. So if you type in calculator, it is giving you 60 meters. And I hope so you got a point very clear. Or we can do second thing. At this point, S is, you can use this equation. S is equal to ut plus half gt square. So one time use s is equal to s and ut is equal to 3. Second time use s is equal to s and t is equal to 4. So we got a 2 equation, and both time gravity -10. Okay, so this is second method. If we use this way, you get a 2 equations, solve them simultaneously, you will get s and t directly. Let's talk about question number 2. Machine for the driving a nail into a block of wood causes a hammer head to drop vertically onto top the nail. So you can see that this is a hammerhead, okay? And the mass of the hammerhead is 1.2 kilograms, okay? And the mass of nail is 0.04 kilogram, all right? Hammerhead hits the nail with speed of V. So it means, this is I discussed here before. This is how you can say this diagram, we make it before collision because collision is going to do, and there's some writing here after collision. So this is a hammerhead, you can see. Okay. And nail is here, you can see the nail even. All right. And if I copy paste this whole thing, or I drag it here simply, so you can see this one, what is going to happen. So naturally when it hit, so they will behave like one particle. Okay, they will behave full as a one particle. So mass of, and read a statement further. Hammerhead hits the nail with the speed of V. So what is speed hitting? You can say that this is u is equals to V, and velocity of the nail is 0 because it was in rest. This is a before collision. After collision, remains contact nail after, he said, remains in contact after hitting, remains in contact with the nail after impact. Impact means after hitting. The combined hammerhead and nail move immediately after impact, speed of 40. So they will behave as a combined object. They will behave as a combined object. And it will go downward, and speed is what here? 40. So mass will add 1.2 and 0.4. If you add them, 1.204 kilogram will act together, one mass. So they will behave as a one object then after hitting. So he said, fine. So you know formula, law of conservation of momentum, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. But now you know that both velocities have the same. So I remove this v2 v1, so it turned to be vv. And if I take vv common out, so what will happen? It will become m1 plus m2 into v. And m1 v1, and this is 0 because this speed is 0, is gone. So I'm plugging the values. Mass 1 is 1.2 into speed is unknown, and is both together mass is 1.204 and the speed is 40. And he said that give answer in exact form. So let me check. 1.204 into 40 divided by 1.2. So it is giving us velocity is coming 602 over 15 meter per second. So alhamdulillah Rabbil Alameen, I believe it is clear. So let's talk about the next. The nail is driven into 4 centimeter, but make sure this is a meter, this is a centimeter, not equal. Anyway, so distance is traveled 4 by 100, and we got 0.04 meters. Okay, into wood, it means this nail will dribble, nail is driven 4 centimeters, okay? Find the constant force, resistance more. Okay, we need to find resistance. Okay, so have a look here. Naturally, it will move inside. Give an example. This whole object copy paste. This whole object will enter the what's called wood. This is wood, okay. So when it enters the wood, because it is already on the peak, okay, that time. When it enters the speed at that speed, you can say it is combined speed is 40. So this, when it enters, this will combine speed. So this is combined speed. So combined speed, and that is 40. Okay, so and then it will go inside. How much will go inside? So it will naturally reach. So it, let's say it travels a distance of this much, 0.04 meters. Okay, so distance. So it will reach here. Okay, and so when it enters, the speed is 40. So u is behaving as a 40 meter per second. And ultimately, when it reach and stop here, why stop? Because further it's not going inside. So last velocity 100% zero. And using this data, we can find out acceleration very easily. In what formula? 2as is equals to v square minus u square. So 2 times 2 acceleration unknown, s is 0.04. And last velocity 0, u is what? U is 40. Okay, so A is unknown. I hope so this part is very clear. Okay. And let me check it. So so negative 40 square divided by 2 and divided by 0.04. So its deceleration is coming negative 20,000 meter per second square. Now I can say that because when it is moving inside, you can say that when a particle moving inside, it's this weight is actually will behave like a force, not a force, but it will, because when it will insert inside, so weight component mg minus friction component, which is okay equals to ma, because when with the nail will enter inside, so there is a resistance by the wood, and that is called friction. So total mass of the whole object, that that 1 point, and mg 1.024 is a mass, and into 10 you get a total weight. Friction force is unknown, mass 1.204 into negative 20,000, sorry. And students, when we just type in calculator and find it. So, so question is coming, how to find this? Is goes there, become positive, and this whole thing comes here. So let me calculate. So 1.204 into 10 and plus 1.204 into 20,000. So answer is coming with me 24092.04. So frictional force is around 3 SF. I don't want. So one add. So 241 and double zeros. Newtons. So I believe the point is very clear. Let's go next question. A block of the mass 8 kilograms. Okay. Slides down. Well, make sure not going up. Angle with a 30 to the horizontal. Starting from rest, it means U is confirmed 0. Okay. And coefficient of friction is given as mu. All right. And block accelerate uniformly down the plane. So acceleration is given as well. Draw diagram. So one mark for diagram showing the force acting on the blocks. So don't make so small diagram. Make a big diagram like the way I make. I'm making okay. Then let's start. And what he said, mass is 8 kilograms. Starting from here, you can assume there's a mass is a 8. 8 tens are 80. So 80 Newton weight. And this is 30. And naturally, it has two component, one parallel to surface, which is 80 sine 30. And one is our upwards acting normal reaction. And one, this is a 80 cos 30. And because it is moving downwards, is a motion this way. So I can say that friction is acting backwards. So I think this part is very clear. Okay, now he's asking what further that, yes, exactly. So now he's asking that find out the mu. Okay, so because system is moving downwards, what is say that weight component minus friction component equals to MA, because the basic formula is what? Net force equals to MA. So 80 sine 30 minus friction equals to mass 8 into acceleration 2.4. So in this way, friction will go this way. And this will come on the other side. We can find friction in no time. So 8 sine, this is a 80 sine 30 is a 40, because sine 30 is half, minus 8 times to 2.4. This value is always half, you know it. Okay. And this is answer. Friction force is coming 20.8. Now, what is our R component is a very clear equal to that. And what is the formula? F is equals to mu R. So F is 20.8, mu unknown, R is 80 cos 30. So 80 cos 30 when it goes down and divide. So let's check it. 80 times 2 cos 30. It is giving us exact value 13 root 3 over 75. But if we check in ESF, it is giving 0.3002. So it means there's no need to take it. So 0.3 is answer. And I believe the point is very clear. So we got friction 0.3. Even you can write exact answer even. Okay. So let's talk about the next part. He said find the speed of block after it moved 3 meters downwards. So it means, you know, starting from the peak 0 speed, acceleration, we know 2.4. Okay. And you know it very well. Look at it, acceleration 2.4, starting from rest. And distance is how much it will travel is a very clear 3 meters. So I think it's very easy to find out the last speed after traveling. So, you know, 2as is equals to v square minus u square. And acceleration is 2.4, distance is 3 meters, and last velocity is unknown u0. And take the root of this one, so 2 times to 2.4 into 3. And take root of this, it's giving us velocity equal to, after taking root, 3.7947. And approximately, because I don't want. So velocity turned to be 3.79 meter per second. So I believe this point is also very clear. Question number 4, mass is given, make sure 1600 car is moving along a horizontal road with a constant speed. When the constant speed comes, acceleration confirms 0 and is subject to constant friction force. This is a frictional force given by him. Okay. He mentioned that we have to find kilowatt, the rate of the engine working. So power, we need to find power. So when you talk about when one car is going, so one object. So for example, one object, there's applied force, this backwards of frictional force. So I can say net force is equals to MA. Applied force minus friction force is equals to MA. And do you know power formula in terms power is equal to force into velocity? If I bring this as a velocity under power, so is power by V, and this is acceleration, you know, 0. This is 0. So friction will go on the other side equals to that. So power is equal to full friction force into velocity. And if I find it, So friction force is a 480 times to velocity 24. And our answer is coming, if you multiply, is coming 11520. So if you divide by 1,000, so power becomes 11.52 kilowatt. So let's go for the next plan. And what the next plan below we given here is saying the car now moves down the hill inclined angle theta with a horizontal. Okay. And sorry. And car engine is working at a constant rate this one. So power is 12,000 watt. And speed of car is 24 at the top at the hill, and 10 seconds later. Okay, it means let's try to make a diagram. So this is horizontal first. It was traveling, then it coming down. And then it coming down. And if you make this, so this is theta. Speed at this moment here, and speed at this. B for bottom, T for top. Okay, speed at this moment is, I will count as a U, which is a 24. And speed at this moment, even just VT, I can say it even. I count because we are not care about U and V, VT. And VB, what is the velocity at the B is 32. Clearly mentioned here. And it will take how much travel to downward time? It will take time, it will take 10 seconds, and distance, I think is mentioned 280 meters. Okay. So I have to draw this height also. Reason to get this height, because we have to go for the energy method. And whenever we go to energy method, we will apply a magic formula. And that is why height is concerned. Okay, and what is asking for? Find, given that resistance is not constant, so it means we have to find out using find total work done by the friction, because not constant. So best technique, we're using the formula. So magic formula. So let's apply. What is the work done by applied force? We have a formula, you know, power is equals to work done by time. So if time multiply with the power, we get a work done. Power is 12,000 and time is 10 seconds. You know it very well mentioned here. So 10 multiplies there. So work done by applied force is becoming 1240 joules. This is done. And work done by friction force is our target to achieve. Okay, now my question, what is a potential energy at a bottom, because height is 0, so it has 0, because mgh, because height is 0, that is why 0. Potential energy, okay, kinetic energy at B, half mv square. Mass is a, hold on, how much mass? 1600. And velocity at a B for 32 square. So 800 times to 32 square, it is giving us 819200 joules. Now, same way, I will find kinetic energy at a top, T for top. Half mv square once again. And 1600 into 24. You can see the 24. And this time, if you check it with the 24, it is giving us 460,800 joules. Now, one last part left only, and that is a potential energy. Look, potential energy, kinetic energy, we got it. Potential energy, kinetic energy, we need to find. one thing left only, and that is the potential energy left behind. Potential energy left behind at the top. So formula is mgh. Okay, m is watt 1600. Gravity is watt 10. Only height left behind. So if I make a small triangle, which you can see, this is a 280 meters. This is a theta given and a height. How to get height? So opposite by hypotenuse is sine theta. Okay, so sine theta. So and sine theta value is given on top 0.09. So I'm keeping it here 0.09 in the place of whole. So 0.09 into 280. I will get height. So 280 times 2, 0.09. It is giving us 25.2. So this height is going here into 25.2. 25.2 into 16000. I get 40,3200 joules. I think clear now. Applying magic formula. What is magic formula? You know it very well. Work done by applied force, work done by frictional force, kinetic energy plus potential energy at an end point with a bottom B minus kinetic energy plus potential starting point, T for top. And this is, you just know it, this one given. So I'm plugging the numbers 1, 2, 4 zeros. This is target to achieve. I'm leaving as it is. Kinetic energy at a B is very clear, this much. 819200. Potential energy at the bottom is 0, so no need to write. Kinetic energy at the top is this much, but make sure outside negative sign. So 460800. Negative into positive, negative, make sure. And potential energy in the top is this number. So 403200. So, so bring it on this side and cancel the negative sign. So I'm typing it now. So 1, 2, okay, 819200 minus 460800 minus 403200 and minus 1, 2, 4 zeros. I'm getting here negative 164,800 and here negative, and this negative and negative cancel out, and we got work done by friction force 164,800. Okay, this is becoming exact, so I'm just leaving this as it is. So alhamdulillah rabbil alameen, clear. Number 5 question, he said it's light string AB fixed point A. You can see clearly, and weight of that is 80. We can see even, and a horizontal force P. So if one person is pulling here, okay, and string makes an angle theta with a vertical line, okay. If P is 32, so we will assume first P equals to 32. System equilibrium. Equilibrium means net effect equal to 0. Okay, so I mean to say above right side force equal left force. So before I start, because due to this weight downwards, so system will feel a tension upwards. Okay, so tension upwards. So this force, this force acting this way, an angle theta. So we have a one force acting this way and one force acting this way. Okay, do you know this line? These are parallel, so this theta and this theta same. Whenever two lines are parallel to each other, and this angle, so this is theta, so this is theta. So this theta and this force T newtons, so we can say T cos theta. And there's a confirmed T sine theta. Okay, now what to do? This is a clear approach. Now, according to the system equilibrium, right side force equal left side forces, and above force equal down force. So I'm writing 2 cos theta equals to 80, equation number 1. Okay, and t sine 30, theta, sorry, not 30, is theta, theta. So theta is equals to 32, because this force equal to this force. This acting left side, is acting right side, balanced. Now equation number 2. You know that sine over cos is 10. So why not divide 2 equation with the 1 equation? When divide 2, sine theta will come up and t cos theta will go down. 32 up, 80 down. Tension cancel, sine over cos become 10 and 32 over 80. When you take a tan inverse, we get answer for angle. And when we take a tan inverse, students, tan inverse 32 by 80, it's giving us 21.8014 degree, which rounding become 21.8 degree answer finally. But if I use this answer, I will not use this answer in any equation. No, I will use this one for accuracy. Okay, so put theta in equation 1 or 2, no problem. So this value is going to plug in here. So t has become 80 divided by cos and 21.8014. And when I divide it by, okay, so what answers turn to be? So answer is turned to be, we're getting here 86.1626. After rounding, you know, 3SF I need, I don't want, which I don't want bigger than 4. Yes, so add. So I believe this point is very clear. Alhamdulillah Rabbil Alameen. Let's go for next part. Instead, the tension is 120 now. Okay. And the particle attached still weight is 80. All right. So P is unknown this time. Okay. So what I do here, students, I erase it and I make it here. Okay. First, I do one thing. I show point A here. And this is pull of P. And this is 80. So I just copy paste. Okay. Now you can see this one. What I'm going to do now, each tension remove and write 120. So 120 cos theta, 120 sine theta. Because tension is actually equals to 120 newtons. And rest part is exactly same. So he's saying find out the P and that. Okay. So I think this is a very clear approach. So this is equal to that. And this way I can find theta very easily. So have a look now. So 120 cos theta is equals to 80. So cos theta is equals to 80 by 120. Theta is equal to cos inverse. I write 8 by 12. Same thing. So theta is becoming, if you type cos inverse, 8 divided by 12. So answer is coming with us. It is coming, let me type in calculator, and answer is coming 48. Let me recheck. 48 is coming. Is this correct number I taken? Hold on. 120. And he said what? Instead is this 120. Yes, this is clear. So 80 divided by yeah, actually one is mistake here, I think. Yeah. Okay. So we got the angle 48 point. 1897. So final answer 48.2 degree. So I hope so this part is clear. Okay, and now he's asking for the P force. So how to find P force? So how to find P force? This value, exact number, and P equal to that. So I'm going to put it there. So P is equals to 120 sine theta, and theta I'm putting 48.1897. And that's it. And when I type in calculator, this is coming 89.44. It means 89.4 newtons. I believe the point is very clear. Okay, let's go for next question. Next question is number 6. Question number 6 is what? He said particle moves in a straight line. After it is again acceleration given by this formula. Okay, let's try, right? Acceleration 36 minus 60. The velocity is given this one and time is this. So this data is given when velocity is 27, time is 2. These are called initial conditions. All conditions only. So naturally, because he said of time, find the times when particle it's at rest. Rest means velocity 0, but we have to put velocity 0 where? We don't have expression of velocity. How to get velocity expression? So first of all, you know these 3 levels. Displacement level. Second level is velocity. And next level is acceleration. So if I differentiate velocity displacement, I get velocity. Again, differentiate, I get acceleration. And if I want to come down, so integrate, this is called integration. And same process, integration. So we are in the level of acceleration now, and we need to find out velocity to integrate. So I'm integrating both sides. I get velocity, integral sine 36 minus 60, and dt must write. What is rule of integration? 36 become 36t, and increase the power by 1 divided by same and plus c1 or c, no problem. Okay, now I will put this data. So I'm putting here, put v is equal to 27 and time is equals to 2. So when I plug in here 27, 36 into 2, this is becoming 3 naturally. So 3 times 2 square plus c. So if I bring all these values left side, 27 minus 72 and plus 3 times 2, 4, 12, I get negative 33. So c value is becoming negative 33. So this value, I'm going to plug in it back in equation. So velocity equals to 36t minus 3d square and minus 33. I got velocity. Now I'll put velocity is equals to 0. Reason to find out the time. Okay, first of all, I will divide the whole equation with the negative 3. What happens, student? Then negative, negative, positive, t square become positive. Here I get negative 12t. Here I get a positive 11 is equals to 0. Okay, now I can factorize, or I think factorization is easy. 11 ones are 11. So negative 11 and negative 1, and I think clear. Or you can apply quadratic formula, but is an easy way factorization, so you should not go for quadratic formula. It's time consuming, this is a time saving. And I got 2 times, time 1 and time 11 seconds. So 2 seconds I got it. And what he was asking, find the time values. Alhamdulillah Rabbil Alameen, we got it. So afterwards, what we next plan is total distance travel in first 12 seconds. Okay, 12 first, and make sure the particle is stopping at 2 points, 1 and 11. Okay, and now best technique, because whenever distance is concerned and the particle is stops in the middle somewhere, there is chances the particle, the object, the motion can go below x-axis, even above x-axis positive, below x-axis negative. So we have to be careful about it. Okay. And so how we can do it, because total distance 4 marks, so I will do a rough sketch. Okay. And because I can see that here it is you see t square okay, let me write this velocity equation first there. This I need again and again here, so I will copy here this velocity. And you know, distance, if I need a distance, as I said before, again I need the distance to integrate. Once again integrate, but before I start integration, I need to sketch it. It is a very important sketching. This is, although examiner not asking for sketching, but it is important. You know, whenever t square negative, I discussed many times. Okay, a few graphs, and I just revise quickly. If plus t, we get this kind of line. If negative t, we get this kind of line. If we have a positive t square, we have this kind of parabolic curve. If negative t square come, we get this kind of parabolic curve. If plus t comes cube, we get this kind of two turning points. If we have a negative t du come, this will flip. I mean, reflect in y-axis. Okay. This is clear. So now currently we have a t square negative. You can see negative signs. So 100% we get this graph. Okay. And when time is zero, like if you plug in times zero here, times zero here, so zero is zero. So what answer coming? Negative 33. There's no need to draw accurate diagram, but just sake of understanding, I can make it, because rough idea only. That is why I'm going to make this graph. And this is very clear. This is negative 33, although no need to show this working. This diagram, just sake of understanding. This time is a confirm one. Once, and this confirm 11. How I know? Because I found 11 and 1 at particle stops, and velocity is 0 on x-axis. And this is ending time. It is a 12. This is ending time. This is the ending time. And you know, this is a negative area. This is a negative area. This is a positive area. So now is a very clear approach. This 0. So 0 to 1, 0 to 1, we will take negative sign, and 1 to 11 take positive, and 11 to 12 negative. Negative. How? So because area coming negative, how to eliminate? So look the way. I will find distance in a one step, not one step. Look at here, but in a one whole idea give here 0 to 1, and I will copy this whole equation here. Okay, dt. But you know, student, I will put outside minus sign. Why I put this minus sign? So this minus into minus become plus. Okay, further I put a plus. Okay, and again I will integrate, but this time 1 to 11. And again I paste here. Okay, space issue, so I erase it. I drag the whole slightly back. Okay. Now again, I put negative. Why negative? Because this is negative. Now 11 to 12. And I will write here 11 to 12. Again, I paste equation here. And dt must write at the end. So I hope so you got it, students. What is the planning behind this? Okay. So distance is actually is equals to this whole equation. I repeat why I kept negative sign. You know it very well, because this area below x-axis, that is why. And why I put positive? Because above axis. So I think we can do it now. So if I do it this one, so what is integration? 36t to power 2 by 2. Here 3 increase 3 powered by 3, and 33t, and 0 to 1. And I will not waste my time, because this will continue throughout same. here, here. Okay. And here I put plus sign, here I put minus sign, and limits are not this one, different limits are there. Here limit is 0 to 1, 1 to 11, and 11 to 12. Okay. Now I simplify, and I think so. If I simplify, and what is best way of simplification? This I got 18 t to power 2 negative t cube and negative 33t. And again, I will put the limits. So same story, I will do it. Let me check to 18 times. Yes, correct. Okay, so copy, paste, and even paste here. Okay, this is a positive and this is negative. And again, this is a 1 to, this is a 1 to 11, and this is 11 to 12. So just plugging the numbers. And if we plug in the numbers, so upper number minus lower number. So here answer is coming 18 minus 1 and minus 33. This is coming negative 16, but negative plus 16 will come from here. And if you plug in here, 18 times 2, 11 square minus 11 to power 3 and minus 33 times 2, 11. I get 484 minus. And when I plug in 1, so I get again negative 16. And this become positive. So 484 and plus 16, we get a 500. Okay, this one is what? If we check it, so 12 and minus 11. So it is giving us 11 giving us, 11. When I plug in 11, I got 484. 484 and 12 is giving us, anyway, I'm plugging here first 12 and then 11. 18 times 2, 12 to power 2, minus 12 to power 3, and minus 33 into 12. So 468 and minus 484, which coming 16 negative. And this negative into negative positive automatically. And answer is coming here 532 meters. I believe you got a point very clear. Question number 7. Question number 7 says what here? He mentioned the particle A mass is 0.24, B mass is 3.3, and the smooth pulley, that is always smooth pulley, and the rough plane, okay, and angles given theta, sure, and particle A is there, B is there, and he mentioned that the height is 1 meters and coefficient is mu, which is unknown, we need to find. If theta is 30, so I take is 30. Okay, what happens then after that? He said system equilibrium, it means acceleration is confirmed 0. Okay, so point of slipping, moving directly up. It means, first of all, I show you this is a 3.3 into 10. This is 33 newtons. Tension towards pulley for sure, that you know always. And this 2.4 into 10, we got is 24. So this is for sure 24, and angle is 30 degree. So 24 sine 30. And this is what R acting upwards. And this is what 24 cos 30. Because it's about to move up, about, I will write a word, about to move. So friction is naturally backwards. It's a very clear approach. So let's try to solve it. Okay, and when you try to solve it, so what is the basic formula, students? Net force equal to MA, but I will apply for 2 objects, one for A object, one for B object. When you try up here, net force equals to MA. And same formula here, net force. So when because this about to move down and this tension backwards, so 33 minus tension equals to 0. Tension become 33 newtons. And when you talk about the other A particle, because about to move, so I'll start from tension minus friction minus weight component. So tension minus friction minus weight component, 24 sine 30. If you type in calculator, it's giving you 12. And mass is of the A particle is 2.4 and times to 0, no need to do it. So, and friction will go on the other side, become positive, and tension, I got 33 minus 12. And I got a friction is coming from here, 11 newtons. And 11 newtons, I got it. And we know what is the formula of F mu R. And mu R, and R is just, we know it, if you see carefully, R is equal to 24 cos 30. If you type this in calculator, it will give you 24 cos 30. It is giving you 12 root 3. And it will go down, so it will go down, so 11 over 12 root 3. And if you type in calculator, let me check, students, 11 divided by 12 root 3. It is giving me, hold on, some mistake. I have typed in calculator. 24 into cos 30 is a 12 root 3. That's correct. And hold on, what is mistake here? 33 minus 12. Oh, this is a 21. Sorry for that. This is a 21. So this is a 21. Okay, so 21. Now, if I check it, 21 divided by 12 and root 3, my answer is coming. His answer is coming 21. So 1.01 proved. He was asking for it. Okay, which is matching. You can see here. Okay, next part. He said that instead angle is 20 now. Okay, and system is released from rest and string taut. Okay, find total distance traveled before it come to rest. Okay, so let's make it a little bigger diagram because this question is a little bit tougher. Okay, a pulley here, particle is hanging here, and this is a 1 meter, and this is, I think, 3.3, 33 newtons. This is a 33 newtons tension towards pulley, and this particle is here. Okay, and it is attached here, tension. And downwards, you know, 24 sine 30 is 12. It's very clear. I'm writing this 12 only, 12 newtons. Okay, now situation is very clear because system is moving downwards. This is a motion. It is a motion this way. Okay, so let's talk about the B particle. B particle, I can say here, B particle. Net force equal ma. 33 minus tension equal ma. 33 minus tension equal to 3.3a. So A particle, tension minus weight component and minus friction component. And friction component, you know, is equals to mu r. Mu is 1.01. R is, you know, I just said you, this is a watt component, 24 cos 30, which come what? 12 root 3, 12 root 3, 12 root 3. So if you type it, this answer into 12 root 3, it is giving us 21 Newton. So you saw, students, the same value came here. So no need to work out. It means you learn one lesson. So this friction get a previous part remain same because object same, forces same, so everything's same. Force is not a concern. Mass and friction, mass and the surface of nature. So tension minus friction minus 12. So I can say here a particle net force equal ma tension minus friction force minus 12 is equals to ma. And what is the mass? I think it's coming 2.4a. Let me recheck. Yeah, 2.4. Correct. Okay, this is becoming 33. So 33. Okay. And then wait a minute. 12 tension. Yes, so it is coming from here. Hold on, 21. So 1.01 times 212 root of 3. Yeah, this is a different number I'm getting here. It's not 21 sharp. Actually, it's coming 20.99 because we have to use that same value, 20.99. Okay, also is same, but we have to use same. Okay, anyway, so 20.99. And wait a minute, let me recheck that 33 minus tension is MA, and tension minus weight component. And hold on, this is a 24, so this is a 12 is correct. And actually what is going on is both are, but no, they will not cancel. So naturally the small numbers difference is there. So it means this, we have to take friction component, not 21. We have to take it, we have to take the other number, what is mentioned here, 20.99, not exactly 21, slight difference is there. Yes, student, is one correction is there. Actually, this angle is not 30 now. This angle is 20. That is why I saw answers are changing now. So this is will change even. Okay, because I said you the angle will change. So then we can say the frictional force can affect. So you can see this one. So what is of this mu r now? This r is before 24 cos 30, and now it's become 24 cos 20. This is 24 cos 20. So let me check now. 1.01 into 24 times 2 cos 20. And I'm getting here 22.7, you can say 778 newtons. And now it is a correct now, and the rest is no effect. And even here a small effect is coming. Okay. How come this is not 12 now? So will change. This is becoming 2.4 times to sine 20. So when I talk about, so tension is coming here, minus friction component here. Look, first of all, let me write the formula. Then you can understand. Equal to MA. Okay. Friction force, I just got it from here. And if I type all together, both values, so let me check. Plus 2.4 times 2 sine 20. And this answer is coming 23.59. 23.59. Okay. So it means I'm getting here 23.59 is equals to 2.4a. Okay, now if I solve it, so if I solve it, what I get it, wait a minute, let me check again. This is if I cancel, okay, let me write the both values. 3.33 tension equal to 3.3a, students. I copied this equation, done. So tension minus 23.59 equals to 2.4a, done. So tension cancel out, and from 33, if you subtract this, so I get 9.401, and here I get a 5.7. So we divide 5.7, we get a acceleration 1 point. I think still we are getting some error. Wait a minute. What is a mistake? Actually, I just started. Yeah, he said mu 1.01, correct? And angle is 20 degree. Let me type again. So mu r 1.01 into 24 times 2 cos 20. This is a 22.78 is a correct. I just tested now. And the weight component is what? 2.4. Oh, this is a 2.4 I wrote. This is a 24. This is a mistake actually. This is 24 actually. So that is why 24 times 2 sine 20. Yeah, it is coming 8.2. Now it's correct. This is a mistake actually, student. That is why. Okay. So it means this is a 24. And now I'm checking 24 cos 20 and plus 22.78. Yeah, it is coming now, correct? It was first negative 30.99. Negative 30.99. Okay, now if I type in calculator, so if I subtract from this, so what I get, 33 minus this value, I get a 2.0115 divided by 5.7, and I'm getting here 0.353. 0.353 meter per second square. So I think this part is clear. Okay, so this is not our final answer. Let's go for the next plan. What is the plan he talk about? It means this particle will fall with acceleration of this, and this particle will move with acceleration of this. This acceleration will work until it will hit the ground. So let's talk about that part. I'm saying here for B particle. Here I'm making a plan for B particle. For B particle, B particle starting velocity is confirmed 0, and distance to travel is 1 meters. Very, very clear. Acceleration, I just got it 0.353. Okay. And I need to find last velocity. Last velocity is the main target. I tell you why. 2as is equals to v square minus u square. 2 times to 0.353 into s1, and last velocity is unknown u0. If I take a root of the whole, so let me check into 2 and take a root of the whole. So I get the velocity 0.8, 0.84 meter per second. Okay, recheck once again. 2 times 2.353 and take a root of this. Yes, 0.84. Student, it's a very important thing to know. If I say that the particle is coming, for example, just about to hit the ground with 0.84. Okay, it is a very obvious. You can see. So what is the situation we have? I show you the next diagram. Wait a minute, I have space. Yes, I have a space. So what I'm going to do, this diagram, I'm going to show you second idea, second picture. Then you can realize. Okay, copy and paste here. Okay, so look, students, this particle will fall 1 meter downwards, and this particle move 1 meter upwards naturally. Okay, what is speed at this moment? Speed at this moment, I got 0.84. And what is speed at this moment is also last speed is 0.84. For this motion, last speed is 0.84, but it will not stop. It will slightly go up. This is called motion due to inertia. Motion due to inertia. Or we can say inertia motion, inertia. Okay, and 100% it will stop on the peak. So last velocity is confirmed 0. Okay, for this motion, what is starting speed? This ending speed of this motion is 0.84, will become starting speed of this. So it means u is equal to 8.84. But problem only one left. And what is my target? Find out s. If I get my distance here, my question is over. But thing is that, do we have acceleration here? No, we need to find. So how to find acceleration? You know it very well. Tension upwards, weight component downwards, and friction downwards, and 24 sine 20. Okay, according to situation, net force equals to ma. Okay, it means I can say here tension minus force minus 24 sine 20 is equal to ma. Mass is 2.4, acceleration, but tension becomes 0. Logic, because when this particle will hit the ground, when this will hit the ground, so tension becomes finish, over, and this tension becomes 0. So that is why I'm keeping 0 here. So negative friction, and negative friction, what is the friction value? I just found here. I found here 22 point, because angle same 20, that is why. We can't use the previous one, the 22.78. 22.7 is 22.78. And minus 24 sine 24, 20, sorry, and divided by 20, 2.4, we will get acceleration. So let's see. So negative 22.78, negative 24 times to sine 20. And what our answer coming divided by 2.4. And my X answer is coming negative 12.9 meter per second square. Now I can use this inertia for a particle. Okay. So naturally last velocity is 0. How come? It stop last velocity. And this final velocity of this motion will become starting velocity of this motion, 0.84. So u is 0.84. And acceleration is negative 12.9. S is a target. So 2as is equals to v squared minus u squared. S is what? Unknown. While last velocity is 0, u is 0.84 square. So S is coming. Let me check 0.84 square and divided by 2 and divided by 12.9. And I get it here 0.027. Okay, 7, even after 7, 3. So if I round it 3 SF, I don't want. So even it's becoming 0.02, but I think so we can do 7. Okay, yes. So total distance become what? Total distance. So total distance, you know, student, total distance is 1 meter and this. So add them both. Okay, let me check. Did he mention some special format? No, he did not mention. Sometimes you say 1 dp or 2 dp, but he did not mention. So 1 plus 0.027, it become 1.027, or you can say now with 3 SF I'm looking for. So 1.03 meters. And I believe the point is very clear. And this was a little complicated question due to angle changing only. And I hope so. The concept is very clear and question is over and paper is as well over. I believe you understood a paper. And please practice, because without practice, you will not improve. Best of luck for exam. Assalamu alaikum wa rahmatullahi wa barakatuh.